workable state is basically a working prototype. An advanced prototype, maybe a beta version if you want, but still something implemented by myself plus, physicists.
And just to jump on this, so at that point, and maybe I just didn't understand fully what you were saying, but at that point, would you foresee that in this language you would actually be able to write like fundamentally new code, like in any generic language? What I mean is that to be able to express types of analyses that were not foreseen before.
Okay, try and make it a quick answer because we're running a little bit late. Remember, folks, we have the workshop notebook to carry on the discussion.
Sure.
Okay. Since we have a number of logical and mathematical operators, any function that can be expressed in terms of existing internal functions can be written. Transverse mass of W, of course. But if you have a complex function, something that is the result of a machine learning algorithm, if you want, that can be added as an external user function, compiled once, executed at runtime.
Super, thanks Gökhan, and thanks for the interesting discussion, but we'd better move on to make sure that we get a little break as well. So the last contribution in this session is another real quick one, which is going to be Thomas will be telling us about what's been going on inside of PODIO. So I'll let you share your slide.
All right, so I trust that you see my slides and you can also hear me.
Yeah, so go ahead.
Right, so I'm just going to give you a 5-minute whirlwind tour through PODIO, what it is and what it does, and what's the newest developments in there. So first to start, EDM in this case doesn't stand for electronic dance music, rather it's event data model, and hence this talk starts a bit earlier than the others in this session in the analysis toolchain from data taking to actual analysis. For illustration purposes here, I have chosen EDM for HEP, mainly because it uses PODIO and also because it has this nice diagram on the left side that lets me explain some of the challenges that one faces in implementing such an EDM. So for one, we have to support relations between the objects in the EDM. We, of course, want to be the whole EDM to be efficient and have a performant I/O below it. Nowadays, it better be thread safe. And of course, as always in such systems, it should be easy to use without going into too much detail what easy to use in this case means. So where does PODIO come in? PODIO basically is just a design principle, let's call it like that, that employs a layered design where we have at the highest level a so-called user layer, which basically consists of handles to the objects in the EDM, and this layer offers the full interface. It lets you navigate the relations and everything like that. In PODIO, this layer offers value semantics, so it should be easy to use. The user doesn't have to care about managing resources or pointers going out of scope and stuff like that. All that is managed by the so-called object layer, which apart from the resources also handles the references to the other EDM objects. Below all of this is the pod layer, where we just store all the data in plain old data structs. And with this layered approach, we hope, or we claim that we can have an efficient memory layout, and also that we can implement the performant I/O system beneath that. And since writing these 3 layers for each and every EDM object in your EDM is kind of cumbersome and becomes boring pretty quickly, we've also implemented a code generator that takes as input a pretty high-level description of your EDM in YAML format and turns this into all the necessary C++ code, which can then be compiled and used. And since just generating these files is not enough, we also now offer some CMake macros to facilitate the downstream usage of this code generator and everything that comes along with it. So on to some new features. First, we have added a new persistency backend based on the SIO library. This library is used in the linear collider world in LCIO, the EDM there. We have designed it such that it can be used as a drop-in replacement for the default root-based IO backend. We've done some very preliminary benchmarks using the aforementioned EDM for HEP EDM and using the Higgs recoil at ILD as a physics case. You can see the summary of this benchmarks on the right. Root seems to be slightly faster for writing and yield smaller file sizes. On the other hand, SIO is slightly faster when we read in the whole thing, and we also have slightly less variation in per event times. This is something I put into the backup. However, we didn't actually implement this SIO backend to just play it against root. The main purpose here was to confirm that this layered approach of PODIO is actually able to support multiple backends, and it's more or less easy to just add a new backend if the need arises for some reason. Another new feature. Sorry?
A minute more.
Yep, perfect, thanks. Another new feature is metadata, which by definition is data that provides information about other data, and it is necessary sometimes in an EDM to store information that allows you to correctly interpret the information stored therein. In PODIO, we have deliberately limited the capabilities of this in order to avoid the situation where you build a second EDM using metadata. So since it's easy to fix your EDM, do it, don't work around it. We have a prototype implementation ready that basically allows you to store strings and numbers with some labels. However, thread safety is not yet completely solved, and you can store this metadata at the run, collection, and event level. Some next steps and future goals. The most important one and the major one for the moment is we want to make PODIO a bit more self-contained so that it can be used outside of frameworks like, for example, Gaudi, and then make it a bit less heavy to use in that regards. And we then want to tackle thread safety and thread policy for this, most importantly for the metadata feature that we have. We want to have more benchmarks, of course, and then there are already a list of open issues on GitHub. If you have ideas or requests or issues, feel free to add them there, and we will promptly react to those. Thanks.
Great, thanks very much, Thomas. Short but very clear. So first question from Andy again.
Hi, thanks, Thomas. Very nice. You focused very much on I/O and data storage, but the EDM is also highly involved, of course, in execution, right?
Yeah.
Some of us who have been at CHEP 2016, I think we had a long discussion about test beds of trying math libraries, vectorized S matrix, eigen whatsoever. So does PODIO support the definition of different custom math libraries? You define your vector 3D there, right? Now, can I choose S matrix 3 or an eigen matrix 3-1?
Oh, that's actually a good question. Currently, not yet, because I mean, there is an EDM for example, there is a vector 3f and a vector 3 double, for example, but those are really just structs of 3 doubles or floats. The reason for that is that currently the code generator also validates that everything that is a member of a data type is can actually be stored in a pod type. So as soon as you have something that's non-contiguous in memory, the whole pod layer approach sort of breaks down. And currently we just restrict this to the built-ins basically, but I suppose eigen, for example, uses contiguous memory, so that is nothing that speaks against this in principle. However, I have no idea how hard it is to actually get this into PODIO.
Thanks.
Thomas. Enrico, question from you.
Yeah, thank you for your presentation. I was just curious when you mentioned that you're a bit faster in reading than root. Of course, the root team, we would be interested in knowing if you know what is it that makes you a bit faster. There's probably something that can be done either at the level of the benchmark or the level of root IO to improve root performance then.
Yes, so again, the benchmark, nothing has been tuned, neither in SIO nor in root. Root certainly offers a few more knobs to turn in this regard. If you go to the backup or I just have the backup slides here where I show the per event read times for SIO and root. And as you can see, 90% of the events are read equally fast in SIO and root. And then what pushes root to the overall longer read time is simply the rest of the 10%, which can take significantly longer in root than, for example, with SIO. With SIO, we are done in 2000 microseconds with all the events, but for root, we sometimes take up to 2 orders of magnitude longer. And we haven't done...
Do you know what's taking, what's causing those long tails?
We haven't done any investigations into that yet.
Are these benchmarks public?
Not yet, but we can certainly make them available.
Yeah, please ping us when you do. Thank you.
Okay.
Do you know what compression you use or what compression SIU uses? Because I think that's the key here.
SIO as root in this case should both use CLib in the background. In principle, we have configured root to use the same compression level as SIO, so that is something that should be the same in both cases.
Okay, interesting.
Okay, great. Something to follow up on there. One last question, I think, from Ben before we go to the break, or even 2 now.
Sorry, was that to me, Graham?
Yes, it's to you, Ben. Go ahead.
Yeah. Okay, well, the first was just a very quick comment, which was just to say it'd be nice to obviously link this up with Phoenix at some level. I think Graham's question earlier about the event data model covers that. But the more of the question side was how easy and hard is it at the moment to integrate PODIO? So say I develop an EDM in PODIO, but I'm using another framework, say for event processing like Gaudi or Art or an experiment-specific one. Are there sort of examples already of doing that?
So in the key for HEP stack, PODIO is actually used within Gaudi, so that's definitely possible. And also for the rest, it should be pretty easy. I mean, basically the collections offer an interface that you have to basically fulfill on how to read and how to write the let's call it data buffers. And as soon as you hand off these raw data buffers to the collections, everything else is handled for you. But currently we are also working on having this a bit more easy standalone, just also as an example on how to make this integration of from data to actually usable collections in the end. But in principle, it should be rather easy. That's the basic.
That's great, thanks.
Okay, thanks for that discussion. And I think here we can close the first session. So people can go off and make tea, coffee, or pour themselves a juice as is appropriate. So my thanks to Ed, Vincenzo, Pieter, Gökhan, and Thomas for giving such interesting presentations and pretty much